Hi, here we're going to talk about exponent rules. Here is a basic example. We have 3 to the power of 4. We call 3 the base, and 4 is our exponent. And exponent just tells us to repeatedly multiply by a number over and over again. So for example, 3 to the power of 4 would be 3 times 3 times 3 times 3. I just multiply out 3 times itself 4 times. The standard form is what we call the answer. And the answer would be if I just multiply it out. So I would do 3 times 3, which gives me 9, times 3, which gives me 27, and then times 3, that would give me 81. So when we evaluate 3 to the power of 4, we get 81. So a few other rules we want to look at is how we work with negative symbols and grouping symbols when it comes to exponents. And there are some differences in the way we evaluate some of these exponential expressions. First thing we'll look at is negative 5 to the power of 2. To explain these, we're going to expand each of these expressions. What I like to do is rewrite this negative 5 as if it were multiplied by a negative 1. So I'd rewrite this as negative 1 times 5 times 5. There's only one negative, so my answer is negative. When I multiply that all out, I get negative 25. The next one, the entire negative 5 is being grouped. So that entire expression gets multiplied by itself. So I rewrite this as negative 5 times negative 5. Two negatives make a positive. I get positive 25. So you can see there is a difference in these two expressions. Furthermore, what if we have more going on here? How about negative 3 quantity squared? Well, I'd rewrite this first negative 1 up front times negative 3 times negative 3. And then I look at the number of negatives. A negative times a negative is a positive, times a third negative would make it negative again. So 1 times 3 gives me 9. So my answer is negative 9. Another example, what if I have a number, a multiple outside of an exponential expression? I just go ahead and expand that out to solve it. So I'd have negative 3 times negative 1, which is kind of out in front there. It's hidden, we don't have to write it down, but it's there. And then times 5 times 5. These two negatives multiplied together become positive. So I'm left with 3 times 5 times 5. I can do 3 times 5, which is 15. And 15 times 5 gives me 75. So the next thing to do is to look at is looking at powers of 0. Simply put, anything to a power of 0 is just 1. So if I see 10 raised to the power of 0, it's 1. If I see negative 5 to the power of 0, it doesn't matter what the sign is, that's still 1. If I have 1/2 to the power of 0, since this entire number is being raised to the power of 0, that's just going to be 1 times 3 squared, which is 9. That answer is 9. Next, I look at the denominator here. I have 0.4 to the power of 1, or I'm sorry, to the power of 0. That whole thing is 1, so I get 4 over 1, which simplifies to just 4. Anything to a power of 0 is 1. All right, last thing we're going to talk about in this video are negative exponents. Simply put, negative exponents do not mean negative numbers. It's a matter of communication. What does a negative exponent mean? To quickly put it together, negative exponents are going to change a problem from a multiplication to a division, or a division to a multiplication problem based on how the number is written. So what I mean by that is here I have 3 divided by 7 to the negative 1. What I like to do is rewrite them with positive exponents. Positive exponents are easier to evaluate. So I'm going to rewrite this as 3 times 7 to the power of 1. When I do that, it changes the sign of the exponent to positive, and then instead of dividing, I'm now multiplying by 7. 7 to the power of 1 is just 7, so I end up getting 21 for the answer. Same idea here. Any number can be written as a fraction over 1. So this becomes 2 to the power of negative 3. I'm going to write that over 1. Instead of dividing by 1, I'm now going to change this to 1 over 2 to the power of positive 3. So what that does, instead of multiplying by this imaginary 1 here, and I'm dividing by that. Anything can be multiplied by 1. It doesn't change the problem. So when I simplify this, I get 1/8. Next we have 3 to the negative 2 over 2 squared. We can start by simplifying the denominator right away. I know for 2 to the power of 2, that's just 4. 3 to the power of negative 2, instead of dividing by this 4 here, I'm going to take this term in the numerator, which I can multiply by 1. That 1 stays there. And now I'm going to divide by that base of 3. Here, this is going to be times 3 to the power of positive 2. And when we completely simplify that, I get 1 over 4 times 9, which gives me 1 over 36. Last one. Just like I did earlier in the video, I'm going to make this a negative 1 out front and rewrite this as negative 1 times 1 over 10. Because now I have a power of 1 there. So I changed it from multiplying by 10 to dividing by 10, and that result is negative 1/10. So that's what negative exponents do. They change the problem's operations a little bit. They do not change the sign of the number.